Dividing polynomials, polynomial division. Today we're only doing example 1, A through D. We are dividing by a monomial. This is straightforward. It's so easy, however, that people may take it for granted that it's so easy that they'll neglect studying for it. So be careful with that, right? Don't get cocky. So here we got 32x to the 4 over 8. Oh, so what we're going to do, whenever it's a monomial, that means it's a one-term polynomial, we divide each term by that one-term polynomial. So it's the first term, 32x to the 4th over 8, plus x cubed over 8, plus 16x squared over 8. And now what we're going to do is simplify that. We're going to simplify that. So 32 over 8, that's 4. X cubed over 8, that doesn't really simplify, so we leave it like that. And 16 over 8 is 2, so it's 2x squared. That's it. That's the answer. That's all we're doing. B. So B has a variable in it. Some people comment, why do some of these have parentheses, some don't? We're not talking about like here. Example D has parentheses around here, but we don't put it on the other ones. They're the same. Okay, so don't get distracted by the parentheses here. Technically, you probably should have parentheses, but I think for the most part we don't. Don't worry about it. All right. So here it's 4x cubed over 4x plus 40x squared over 4x plus 2x over 4x. All right. So whenever we have variables with exponents, we subtract the exponents. So remember, if you don't see an exponent, but you see a variable, it's an invisible 1. So this is going to be 3 minus 1 is 2. And the 4 is reduced, so it's just x squared, right? The 4's cancel entirely, right? The 4's cancel entirely. And subtract the exponents. 3 minus 1 makes 2. Here, 40 divided by 4 is 10. Subtract the exponents. 2 minus 1 is 1, so it's x. And then reduce the 2 over 4 is 1/2. And you cancel the x's, and it's gone. So that's the answer. Right, the x's cancel entirely. All right, example C. Example C. All right, so we're writing it 20x to the 5th over 10x cubed plus 20x squared over 10x cubed plus 2x squared over x cubed, 10x cubed minus 8x over 10x cubed. All right, so here, 20 divided by 10 is 2. Subtract the exponents, 5 minus 3 is 2, so it's x squared. 20 divided by 10 is 2. And if I subtract the exponent, I get 2 minus 3, I get a negative exponent. Well, what's better is you subtract the exponents, but you subtract the big one minus the smaller one, like you're taught in elementary school. Always subtract with the big one minus the smaller one. And put the variable where the bigger one is, where the bigger exponent is. So this becomes x essentially to the 1, right? Because 3 minus 2 is 1. And you put it down there in the denominator. It's x to the 1. Okay, and that's it. And then here, 2/10 reduces to 1/5. 1/5. And subtract the exponents again. 3 minus 2 is 1. And it looks like I copied the problem wrong. My mistake. That's a 3 here. So this cancels entirely. There's no x left over. So that's just a 2. This is the one with 2 minus 3 is 1. Okay? So 2 minus 3 is 1, so it's x to the 1. This is only 2. This becomes 4/5, right? Numerator divided by 8. 8 divided by 2 is 4. 10 divided by 2 is 5. Subtract the exponents. Remember, if you don't see an exponent, the exponent is 1, the invisible 1. So it's 1 minus 3, or 3 minus 1 is 2. And you put the exponent where the bigger exponent was. Okay. If you're wondering why that's the case, let's explore that a little bit. If I have x cubed, let's make it bigger. Let's do x to the 5th over x cubed. Right? X to the 5th over x cubed. That is the same as 5 of these x's that are being multiplied over 3 of the x's multiplied. And what's happening when you're dividing these is you're canceling these x's. So I'm left with 2. Right? So when you cancel like that, you're subtracting. That's the idea of subtracting. let's have it the other way. So I have x cubed on top, x to the 5th on the bottom. Then what I have is xxx over xxxxx. All right? So the 3x's cancel again. And whenever you have nothing left on top, you got to put something on top. It's a 1, right? And you got x squared. So that's why it's on the bottom instead of on top. All right. Last example, example D. So I'm going to do 50n cubed over 10x squared, 10n squared, plus 3n squared over 10n squared, plus 40n over 10n squared. So 50 over 10 is 5, and 3/10. So the n squared is completely canceled. There's no variables in the second term here. 40 over 10 is 4. I got n over n squared, but it's the bigger exponent is in the denominator, so I put in the denominator. So it's n to the 1. Or we don't write the 1. And that's it. That's all we did on Wednesday, January 12th. Okay, so we didn't cover much today. All right, see you tomorrow. Bye-bye.